Thank you, everyone. I'm very happy to be here for my first time in Russia, in St. Petersburg. And today I want to talk to you about something I've been working on for many months already. And I've been thinking about for more than a year because I've been working on the router for a long time. So the title of my talk is SPA Routing Deep Dive with Vue Router. But don't worry if you haven't done Vue Router. The code I'm going to show is TypeScript most of the time, or JavaScript. So it's not really necessary to know Vue at all. But just out of curiosity, who here uses Vue? Oh, wow, OK. For the others, as I'm telling you, there is absolutely no need to know Vue. You will be able to learn pretty much anything from the talk. So my name is Eduardo. I'm from Malaga. I'm living in Paris. And I'm a freelance. I work as a freelance as my day lab, so I can work in between like part-time open source and part-time on projects. And I'm on the Vue.js core team, so I maintain mostly the router, but also Vuefire, and I also do a lot of triaging on Vue core itself. And so Vue Router itself is the second most downloaded package of the Vue ecosystem after Vue itself. And it was originally written by Evan, the author of Vue.js. And I think when I see the code, I can see some things that are not very good. But it's also not that easy to blame anybody because routers are very hard to write. And the reason for this is because they can interact with many layers of your application. It can be authentication, internationalization, data fetching, anything. So the code for Vue Router was originally written, actually it's still written in Flow, which is a typed JavaScript by Facebook, but it's not updated in terms of typing nowadays, not Flow, the Vue Router. So it's a bit hard to maintain, and I'm going to talk a bit about the problems we see and how we want to fix them. So, and I want to tell you, I want to start by saying that because the router is taking a big place in your application, when you start building your application, like the first week, the routing in your application is very cute, like 50 lines. But after 1 year, it becomes a monster of 1,000 lines. It's not maintainable at all. And I want to reassure you, it's the same with the code base of a router. At the beginning, you're handling things, it's easy, but then as soon as you get with the browser quirks, or, oh, this feature request, oh, but it conflicts with this other thing, so we have to adapt the API. Oh, right, but we have to take into account this exception, these edge cases, and there are many. Sorry. The code becomes quite complicated. So let's dive into what a router is nowadays and split up. What is an SPA router? Sorry, wait. Much better. So we can divide the router in two parts, the history and the router itself. And most of the implementations we see out there are like this. So what happens is that the history usually is a specific implementation of if I want the HTML5, the hash version, or an abstract in memory, or can be for the phone, like React Native, whatever. And the router is going to be there to create routes, has the matching logic. So if I enter a specific route, which is the record that is going to match that path, the lazy loading sometimes, guards, which I'm going to talk about in a moment, and pretty much all the public API that you will have. Most of the time, you want to have access to the history component or entity, as you want to call it, or class. You have access to the router, and that's the only part you can interact with as a developer. And then we have for front-end frameworks, we have usually at least two components. Those are the view and the link. View is going to represent the page we're on, and the link is going to be a link that allows you to navigate to another page. And what happens, what I have seen in the code bases of routers, Vue Router included, is that these two entities are quite coupled sometimes, and this gives us some problems. As a maintainer, as a contributor, it's not easy to get into it. And when I was looking at different routers, I found out there are 3 different kinds of routers. So I'm going to show you 3 different kinds of routers. One of them is Vue Router, and one of them is imperative, one of them is declarative, and one of them is configuration-based. You can probably guess which one is configuration-based. The first one I'm going to talk about is Page.js. Page.js is an old router, completely agnostic, so you can use it with any framework, but it's callback based. So it's a bit difficult to use over both, I would say. This is what the API looks like. So you have this page function that you can use for anything. You have, this thing is falling. You have the path, and you say, okay, I'm going to create a page, and when the user goes to this page, I want to execute this function. Inside that function, you have to call that next function. That next function is going to say, we continue on the operation. The reason we have the next function is because we can have multiple what we call middlewares as in Express, so you can drop that at any time. Like the second page you see, the second row you see underneath, it's a user edition, so you have a middleware that checks if the user can be edited, for example, you have the rights. Navigation is done using the exact same function, but without passing a callback. And I would say that Page.js is very simple and flexible, but it's very verbose. And this makes sense because it's completely agnostic. And if you have a recap of all the things we can do, it's imperative, like the API for creating routes is just imperative. You have programmatic navigation, you can call page to navigate in JavaScript. And you don't have any declarative navigation, but this makes sense because there is no framework, so you cannot just write a link in your HTML or in your JS6 to say, I want a link to navigate to a page. You have navigation guards, which are middlewares, and there is no dynamic routing at all. You can add the routes, but you cannot remove them. There is no way to remove them. Then we can take a look at a rich router. So a rich router is a router for React that is considerably less used than React router, but still if you want to read some router code, I recommend you to read this one. It's much more readable, it's smaller, so you're going to have a better time. In Rich Router, the key is dynamic routing. So this is an API that doesn't exist. Okay, they don't have a router instance where you can call add route and remove route, but it's what happened behind the scenes. And it happens when you declaratively use the router component and you nest inside other components that will be your pages. So for example, here you're saying, okay, we have a router, and the home component will be displayed if we match the path /. And then we have the same for the user profile edit. And then you can add links declaratively, which is really nice. The thing is, this is idiomatic for React, so it works very, very well with React because you're used to do declarative things, and it really embraces declarativeness, so you can do things in a very natural way for a React developer. And if you want to recap all the things, it's declarative, although you can also have, I've seen plugins to have configuration-based routing. It has a programmatic navigation, but only JS6. That I may be wrong about that, but that's what I found reading the documentation on Stack Overflow and a bit of the source code. So which it means that you can do JavaScript calls to navigate through the JS6 in like calling the actual JavaScript in JS6. You have the declarative navigation. You don't have navigation guards. This is something you have to implement yourself as components, as hook. And you have complete dynamic routing. You can declare your routes. If the component gets unmounted, the routes will be removed, for example. And here I'll declare inside. And finally, we have the Vue Router. So Vue Router, the API is usually a bit decoupled because we have to instantiate this router first, where you have to pass on the configuration with all the routes, which is an array with order, and then we can create the router link and the router view to link to different pages and navigate. So it's decoupled, and we use a router instance and components as a public API. The Rich Router also uses components at the public API, but you don't have these router instance you can access. So if you want to recap that, we have a configuration-based approach. We have programmatic navigation, we have declarative navigation and navigation guards, which is a specific feature that we see in Vue Router. And we have partial dynamic support. So we can add routes, but we cannot remove them in a clean way. You can use private APIs to do it. The thing is, and I will explain why we cannot do this, is because it was never thought to be used that way. So there are a lot of problems that arise. Now, if I want to dive a bit more in the Vue Router, the thing is we have components, a router communicating with themselves. And the history is hidden behind that. Okay, we never have access to the history. We are only interacting with the router through the components or the router itself. So, what is the actual responsibility for this history? The history is supposed to store the visited URLs. And I'm not talking about history, the HTML5, the JavaScript object that exists in window point history. I'm talking about the entity that we use in a router, the class history that we use, which will use the window.history, by the way. So this class is supposed to store the visited URL somehow. It's supposed to make the communication between the JS and the URL, if there is one, if it's visible, whatever. And it's supposed to expose through some APIs like push, replace, and you can communicate that way. And finally, you have this listen function that allows you to react whenever the URL, the location changes. Now, the thing is, depending on the implementation, depending on the platform you're on, this can be very different. On a mobile, the listen can be just the back button, for example. On a browser, there is also the forward button, for example. And then we have the router. Now, the router has many responsibilities. It has the route matching, so these will apply to two functions, match and resolve, and we'll see that resolve actually uses matches, so it's a bit redundant. We have navigation, so we have which is the current route we're on. That's a useful information for the router view, for example, and the router links. And we have push, replace, we have before each, which are the guards, so we can cancel, like abort navigation, redirect to another location if the user is not logged in, anything. And we can create routes through two ways. The new router or add routes, but you cannot remove them at all. And then the components, where I showed them multiple times, but just to get you a quick view, we have router view that we use like that. I have router link with a to-prop that allows us to say, where are we going? So these are pretty much the good part, okay? And we're going to talk about things that are, I'm going to dive a bit more in the things that we want to keep in the router, because we have seen that they prove to be very worthy of a router framework, and they actually help a lot of developers to build more complex applications in their router systems. So the router OLED, for example, communicates with the router instance. Decoupling this way allows us to really encapsulate the changing of the current location on the router itself and handle all the reactivity at the Vue component level. So we can actually create a router that is very agnostic to Vue, and this is very cool, because we could imagine that in the future, the code for Vue router could be used for other routers, for other frameworks, although it's not the main intent at the beginning. So the only responsibilities here is dynamically rendering the current view and passing the params as props if we decide so. Then we have the router link, which is a bit more complex and is also communicated with the router link. So it's going to resolve the target location using the matcher I told you about before, and it's going to render an anchor tag, and it's going to handle the click event, so it prevents default, so it doesn't navigate to another page, and it's going to apply the active class. Now, the active class behavior is a bit complicated. It looks easy. This is the kind of things that look so easy when you use them, but there are so many edge cases you have to take into account that it's not that easy. And you realize that when you fall into one of these edge cases, and you start searching for issues, and like, oh, well, it wasn't that easy as I thought. And you see the issues closed. Now this is working as expected. Now this is working as expected. And you're like, oh, shit. So this active class mechanism is a bit more complicated. I won't dive into it into the talk, but I will be able to talk about it afterwards if you want. Now, the other things that are very good in Vue router implementation nowadays is access to the route everywhere. So in Vue, you can access to this route via $route. And this is a normalized version of the location we are on. So it means that the object always looks the same. It's a normalized version. And this is very important because we're going to use normalized locations very often inside of the router. And we only have, like we call raw locations in the public API. So the user can provide, so the developer can provide an easier version of the URL. So what a route looks like, it's a path, a name, a query, the params, the meta, and there is also a match array. So we can go as complicated as we want here, but the most important parts are the path, the query, and the params. Those are the information that belong to the URL, and they are parsed in a format that you can use in JavaScript. So the idea is you can, for example, display the ID of the user you are looking at, and you can use the ID to fetch some information on your JavaScript. You have this double mechanism. You can use it declaratively in the template, but also use it imperatively in the JavaScript. And the last thing we have is this $router, which gives us access to the exact same instance we created on the router.js file usually. And this allows us to do programmatic navigation, basically. That's pretty much what we want to do. So we can redirect the user if they have some complex interaction that you don't want to handle with a simple link because it's too complicated. Now, let's talk about the ugly parts, because all the things we have seen so far are things that I want to keep, and I think there are good choices and do not create problems among users. The ugly parts, they come mostly from a no clear division of responsibilities. And this is funny because when you look at the API of Vue Router, you cannot see this. When you use the API, the implementation behind doesn't matter at all. You're only passing the guards to router before each or to a component. It's very easy. But the truth is, in the implementation, there is a clear overlap in between these two classes, the history and the router. And this is where the sadness brings in, okay? For me as a maintainer, but also for any contributor when they have to contribute. And I want to talk about global guards because this is one of the clear examples, and I think one of the causes that makes today the Vue Router code complex and hard to contribute in some aspects. So global guards, we have three different we have three different guards in Vue Router. The first one is global guards. So you attach that to the router. You say router before each, and you have this callback. Now the callback is going to be pretty much the same in every single way for the guards. So you have to, which mean where are we going? What is the location where we're going? It's a normalized location. From, which is the normalized location where we are coming from. And next is a function that you have to call, exactly as in Express middlewares. Now, inside this function, you always have to call this next middleware, the function. And you can call it with multiple things. We can call it with false. If you call it with false, you're going to abort completely the navigation. So it means that we stay where we are. We're going to trigger an error handler somewhere, but nothing else is going to happen. If we call it with a location, so that's the first one, the if is not login, I do next login, we are redirecting the user. This means that we are triggering a whole new navigation, okay? So it means that every single guard is going to trigger again. The false is going to abort the navigation completely, and next it's going to say, okay, this guard is validated, you can move on into the next guard. Because the guard are all going to execute in series, one after the other. And they are asynchronous, so we have to wait for every single one of them to finish before executing the next one. Now, the after each is the only guard that do not actually guard, because there is no next. There is nothing to do after the navigation is done. You cannot control anything else. You can just do analytics, for example, but you cannot call next. There is nothing to cancel anymore. There is no redirection to do. You can do router push, router replace if you want, but that's the only thing you can do. So this is the code that we have for the function before each in the router class. We are pretty much pushing the guard into an array and then just returning a function to remove it, like a remove event listener or something. And the actual code is refactored in a function, but I'm not even joking. This is the actual code for adding a guard. So it means that we're holding all these guards in the router class. But when you look at the code for router push, this is exactly the code nowadays for router push, okay? And it's completely leaving the task to history. Like, it's just calling history.push with the same arguments. That's it. So what does it mean? It means that history has to deal with everything. Has to deal with the matching, has to deal with the guards. And this is where my sadness come in. So this is history push, a simplified version, because the code is very complex. It has many callbacks, so it will have no point in showing you this code. It won't be easy to read at all. So the first line, you already see that there is a problem when the history is calling the router API. It should be the other way around. It should be the router calling the history API, which is already the case. But the router should ensure that any information needed beforehand could be passed to the history. So when you see this first line here, you already know that something isn't right. And then what we have under there is a try catch. So we're going to have the navigation guard queue run. And if it works, we're going to change the URL by calling window.history.pushState. This is the case for the HTML5 implementation. For the hash, it will be something else. And then we're going to call the onComplete with the route as we resolve it. And then we have a catch with an error saying, OK, if we fail, if we have a redirection, or if we abort the navigation, we're going to we're going to catch that error and handle it somehow, and then call onAbort. So as a result, when you check the code, you're going to see that the base class for history today is about 300 lines of code. Every other single implementation, like the HTML5, the hash, they extend from this class, okay? And the HTML5 is about 60 lines of code, while the hash is a bit longer because it's a bit more complicated. But then you take a look at the router, and the router class is 200 lines of code. So when you think about it, the router should be more complicated than the history. The history should be dealing with the URL. That's what we said at the beginning, dealing with the communication between JavaScript and URL. And the reason you may think, well, the difference between 300 or whatever, 360 and 200 is not that big. True, but we cannot just look at that. We have to look at the complex, at the code base of history and how you nest function callbacks and you pass callbacks into callbacks. I'm not joking, you will really pass callbacks into callbacks. And it makes the whole code flow much more harder to follow. Whereas the router class, well, first of all, it's a class with a lot of properties that are just taking one line each. So we have a lot of lines that are pretty much 20 lines long, 20 character longs. And then you have functions that are very, very simple, like the one I showed you before the before each. And there is also another thing here is that there is the matcher, which is 180 lines of code, which is outside of the class of the router. And this makes sense in a way, but it deserves a bit more attention. So the thing is, history here is holding pretty much all the complexity. And we are dealing, as a maintainer or contributor, the price we pay for this is just not being able to deliver clear, and not able to deliver more features. So because we don't have a clear division of responsibilities, it's much harder to fix bugs. And I can see that when contributors try to contribute to Vue Router, it's harder to add new features because you don't know where should I add that code. Like if I say that the guards are part of the router, why would you go and fix a bug on the history level? It can happen, okay, there are edge cases, but it's not the first place you're going to look at. It's harder to contribute as a result, because the same is harder for me to maintain, it's also harder for other people to contribute, and it's harder to extend. And this is very important, because, for example, native script is not able to use the Vue Router in their implementation. They have to use something custom. And I would like, in the future, to be able to provide a solution for them that they can extend and use correctly. So let's look again at the responsibilities we were talking about before. We have the history, which is supposed to store visitor URLs and handle the communication between the JavaScript and the actual URL, the location we are at. And then we have the router with all of these things. So it's funny because the history only has a little bit, but yet it's the most complex part. The router has the route matching part, which I'm highlighting in blue because it could be passed into a different class, and I'm going to do that. And then we have the navigation with the current route and everything we said before. Now, let's focus first on the history. So having the API is nice. Like having the API it's important. It's necessary to create our class. But we also have to think about the responsibilities. What are the boundaries? What things the history is not supposed to do? What things is the history supposed to do? So think about the responsibilities and expectations that you have from the history. For example, the history is expected to modify the location. You should be able to call a function to just change the URL, whatever it is, whatever it means for that implementation. It should handle the URL parsing. And by URL parsing, I don't mean transforming the user ID into the parameter user ID. That will be the matcher. What I mean is splitting the actual URI into a path, a query, and a hash. And the query should be also parsed into an object that has the values passed as strings because it's a URL, so it's always a string. And so all of these can be contained into a URL parsing toolkit, utils, that you can use across every single implementation of the history, every single extension that we use. But not only, we don't have to forget about the notifies when the location changes. Now, the other thing is, we have two other things, sorry. We have the handling and coding problems. This is funny. You can imagine where we are going. And it's to also be able to be overloaded. And this is just the native script issue I was talking about. I want native script to be able to provide a new implementation for the history so they can use the same router. They have to create a new one. So as a result, in the rewrite I'm doing right now of Vue Router, for example, the base history is 10 lines of code. Why? Because there is no code inside. It's just an abstract class. So it doesn't actually produce any code. It's just TypeScript. But then there is 150 lines of parsing, and it will probably go higher as I move forward. And then the HTML5 is 200 lines of code, with a lot of comments, to be fair, but it's still containing most of the logic. It's still containing the logic necessary for only handling the HTML5. So let's take a look at what an ideal push function of the HTML5 class should look like. So from this point on, all the code I'm going to show is inspired by the current, like the new rewrite of the Vue Router. So it means that it's not exactly what I'm writing, but it's very similar, or is things that I'm intended to write. Most of the things I'm showing I already implemented them, but some are not yet implemented. And of course, for the sake of just showing and teaching it, I have removed some of the aspect. So for example, you won't see any scroll behavior handling, which is a pretty tough topic if we don't just show a function, you call a function instead of showing the whole code, the code. And the whole code is also written in TypeScript. So you will see a lot of type annotations all over the place, but I will try to explain them as much as possible so things are clear. So the first thing we see here is the to, which correspond also to the target location we want to go, and it has a type history location. Now, a history location is basically a string or an object containing a path, a query, and a hash. And everything except for the path is optional in the object itself. And so that's why the first thing we do is what? Is normalize the URL. We want to have a normalized version that we can use across our code, so it makes everything easier to handle, pretty much. So we normalize the location with the utils that we talk about. That's the URL parsing. We transform that into an object with, if there are no query parameters, an empty query object. If they are, an object query with the parameters they need. And then the hash, which can be an empty string if there is nothing, and a path, etc. Then we have this replace state. Now, this replace state we see here is to be able to check if we're moving forward or backwards when we're navigating through the buttons of the browser. So what I'm trying to say is that nowadays, if you, well, even without a router, if you just listen to the pop state, which is the event that is triggered when you click on the back and forward button in the browser, you don't know if you're going backwards or forward. You have to implement that yourself. So this is pretty much what we're doing here. We are replacing the state to say, okay, so the place where we're going from the place we're right now is this location, this normalized location. So we are just spreading the whole state we had before, and we're adding the forward location. And then we have this other state, which is the new one. And we have back, which is the current location. We have current, which is the location we are going to. And then we have forward, which doesn't exist because we haven't navigated forward yet. We haven't done a push on top of that. And then there is replace, to know if you have run a replace state or a push state, and the rest of the data if you want to see. I didn't say, but the history state at the top, at the beginning of the function, which is an optional parameter, the only reason that's a specific type is because you cannot add everything into the HTML5 state stack. Like some types are limited, like for example, symbols will not be used, like will be completely ignored. So I restricted that with typing so you can have errors at least, and you see that what you pass to the state will be ignored, but as an error instead of no message at all, because that's pretty much how JavaScript works nowadays, right? No errors. And here the problem I have is, oh, it worked. Okay, I wasn't sure if that was going to work because it wasn't work before. That's scrolling on the code. And the last thing we do is just pushing that state and saving the location locally. Now, the reason we do save the location locally is because we want to have a normalized location. This is very important because it's going to make everything very easy to handle. So if we move further, what do we have? We also have a private function that is the setting up the pop listener, the pop state listener. So this is something we call in the constructor of the HTML5 class, and it looks like this. It's just a function, and it's going to return, as you can see. So we have this handler, which is going to be the handler for the state listener, and we're going to only have one. And this is important. So we have at the beginning, we take the state, we have the location we are going from, and we are saying, okay, do we have a location we're going from? If not, we're going to build it from the URL. This is some edge cases. And this is the part I was telling you before. We're going to check if we're going forward or backwards by comparing the location we are going to the state.forward, if it exists. And that gives us the information of a back button or the forward button. And then we're going to trigger every single listener attached to the HTML5 class using this handler. And it doesn't show the bottom, but the button is adding that handler to the window and returning the handler itself so it can be removed later. Now, this is just a small optimization thing. It's just adding one pub state listener instead of adding one pub state listener per listen call on the HTML class, which was part of the public API. So here comes the funny part, the browser queries. So I'm showing you a lot of HTML5 things. We're relying on the window API. And I know what is going through your head. You're thinking Internet Explorer sucks. It should die already. But it's not the only problem. So this is an example I really like. On the left, you have code from Vue Router, and on the right, you have code from Reach Router. And you have the exact same try-catch for a bug in Safari, on mobile Safari, iOS, that pretty much breaks when you do 100 push states. I don't know if it has been fixed yet, honestly, but you have to keep it just in case for older browsers. So one of the quirks, but there are more. And then we have another very cool thing. This is going to be funny. It's encoding issues. So you probably used before, you have probably seen, who have seen the decode URL or decode URI component on the browser, the JavaScript window? Oh, not that many. Okay, so it's something that you should use sometimes when you get, if you want to support Unicode, for example, you have to know that per spec, in the URL spec, not every single character is allowed in the URL. So, for example, character with accents, because the reason I just wrote E with an accent 3 times is to not have a very big URL. Because if I use Chinese characters, for example, I'm going to have more encoding characters. These characters cannot be used in a URL. Okay, we should encode them with a percentage encoding. So who has ever seen a percentage 20 in the URL? I cannot believe only a few you have seen a 20%. 20%, we have percentage 20 is the space character encoded. Because not only do you have the Unicode characters encoded, but you also have special characters when they have a meaning that are encoded. So for example, the percentage itself, you have to encode it, has to be 25. And you have the interrogation mark that also has to be encoded, so it doesn't become the query. So I did this small thing. You have to do it when you're building the router, is testing things on the browsers. You serve a small server, and you navigate to this URL. Now, this URL has a character that cannot be used in the URL. And I use it as the path, as the query, and as the hash to see it everywhere. So you enter in the URL bar, it appears as it is in Chrome, Safari, Firefox, and Internet Explorer. But if we look at the location on Chrome, Safari, and Firefox, we have the encoded version. So we have percentage C3A9. We look at search, which is the query, and same. We have C3A9 equals C3A9. And then we look at the hash, and we have the same. Hash, say C3A9. So great. So what is Internet Explorer going to do? Well, nothing at all. It doesn't give a shit. Just take the whole thing and give it to you. So this, just to clarify, this is not per spec legal. It's not possible. So what happens is that the browsers like Chrome, Safari, and Firefox are not actually passing the E with the accent. They are encoding that and passing them. And actually, if you try to copy-paste a URL that looks like that, you're going to copy the version that appears in the JavaScript. Except for Safari. For some reason, Safari copies the version with the characters. I don't know. And I don't know if you noticed, but there is a player missing here. Well, many players, but a big one today. A browser missing here, someone? Edge, right? So what do you think Edge is doing? Edge, oh, this is a nice pass. It doesn't give a shit either. It's doing the same as Internet Explorer. Now, the thing is, I don't want to overstate on that and talk about from my ignorance, but I know that Internet Explorer follows a different RFC than the URL standard, and that's why they don't encode things the same way. I don't know for Edge, it surprised me, to be honest, because I was expecting Edge to have the same behavior as Chrome, Safari, and Firefox. But the thing is that if you're implementing the router, we have to handle that with user agent. You have to check which browser we are dealing with, and you have to say, OK, if you're Edge, we're going to decode or encode things. So we have the same behavior in every aspect. And the history push state you see on the right, it's just to show you that if you call history push state, you will have the exact same behavior. Chrome, Safari, and Firefox will encode it for you, but Internet Explorer and Edge will just use it as is. So let's go back to the router, and let's divide the router a bit further. I was talking about router matching with resolve and match, which I'm going to suppress here. And then we have the add-in route records, so that will be the dynamic routing. And on the other side, we have navigation, so what is the route we are on, the push replace, so navigating, and then we have the guards and dynamic routing. So that will be the public API to manipulating the matcher. The thing is, we can divide these into two things, the router and the matcher. And this is what we're going to do, because there is enough complexity to have your own entity by itself to do the routing matching. And we're going to see that this has a lot of meaning, actually, because the HTML API, the history API, it's synchronous. The matcher, synchronous. But the router, it's asynchronous, because we have the guards. So let's talk about the matcher first. The API should have the route matching. That's resolve and dynamic routing. And then the responsibilities and expectations, that will be resolving a route location to a route record. Now, the record is what we specify in the constructor of the router, with the path, the component, and maybe a guard, if we want to. And then we have handling the path of the URL. The matcher shouldn't care at all about the query nor the hash. That's the history responsibility. So it will be able to handle the priority of the route records to match the one that is important, and then it will parse and handle the params. So if you have a URL like user/1/edit, it will give you an object of params with the ID :1 as a string. And if we look at the code, so that will be the add route record a bit simplified again. We have different types at the beginning. We have the record and parent. The first one is a route record. So this is what you add in the array of routes, pretty much. And the route matcher is an internal type used by the matcher. That will contain a regex, so you can match against a path, and also the record, so you can detect what component to render. So the first step we have is this create matcher. Now, I won't be talking about create matcher for a very simple reason, is because right now in the code base we use path to regex. So basically it takes the string and it transforms it to a regex. So we can use that regex later. And we give the parent, so we can also have nested routes, so we can handle the children path inside of a parent view component or view record. And what we do is, if we have a parent, we're going to link the children with the parent so that when we do the removal of this record, we also remove all the children for the matcher. This is important. And then with a some simplification, if there are children in the record, we're going to call the add route record for every single one of them, which makes sense. So it's a recursive call. And at the end, what we do is the insert matcher. Now, the idea behind insert matcher is very simple. It's an insertion on a sorted array. But in order to do that, we need a way of sorting. Now, we don't have a way of sorting routes in Vue Router nowadays. And this is why it doesn't work well. Because when we thought about ranking records, we did just by order. When you add a route to the Vue Router, you have an array. So the order that you put in the array is the one that is used to match. So if you put things the wrong way, it won't work. If you take a rich router as an example, they have dynamic routing. They cannot have that. They need a way to automatically handle the priorities. So they have this algorithm that I could explain, but basically associates a ranking to every single segment of the route, and then you sum them up, and it will sort your routes in a descending order. So the one with the biggest rank will have a higher priority to be matched. I mean, that's the way you should work with Vue Router. Now, this doesn't exist in Vue Router yet, but the idea will be to get there somehow, so we can have a dynamic approach and a configuration-based approach as well. Now, the API of the router, we talk about current route, push, replace, navigation guards, dynamic. There is also dynamic routing, lazy loading pages, and you have in-component guards, and you have error handler. As you can imagine, I cannot talk about everything. But let's talk about the responsibilities and expectations. We expect the navigation to be asynchronous. Why? Because we are having all these guards, so we are expecting promises somewhere, and with try-catch and being able to have the rejections as they appear on the navigation guards. It should trigger the navigation guard. It shouldn't let that responsibility to the history or something else. It should be the router doing that job. Then we have to expose the current route location. That's for the component. We have handle redirections. And if we look at the code, a simplified version, again, this is how it's going to look. So we have this async function push that's going to take a 2-parameter, which is a route location, so that can be a string or an object. Again, it's a non-normalized version. And it's going to return a promise. Now, the first thing we do is this resolve location, which I'm going to show afterward. That is going to pass the route we want to go to and the current location. This is because of relative routes, which is a feature of Vue Router, where you can just pass the params and it will use the current route to just change the params of the route, but still stay on the same route. And then we have this try-catch, and this is very important, and you will understand why as we go further. This navigate is going to contain all the logic for the guards, the navigation guards. So it's going to patch the to location, normalized, and the current route. And then we have the catch error, where we can have many things, and we're going to see the type of the error to handle it differently. So for example, if we have a navigation guard redirect, if we call inside of the router navigation guard next with a link, like /login, it will throw this error. So here in our code, we will catch that, and we trigger the whole navigation again, with all the router guards again. And there are other errors to handle. There are other errors to handle that have not been handled here. But basically, any other error, we're just going to throw it, so it can be caught as a rejection when we call push. And will it work? OK, this is going back again through the thing. It doesn't work. Then what we do is we replace or push the URL with a history. So this is what we call history.push and history.replace. And this is the only place we call it. So once we get to this point, we know that the navigation has been confirmed or has been canceled. But if it has been canceled, we throw an error. So we just drop out of the function. So we change the URL on the browser, and then I'm going to prevent doing this. We're going to save the current location as a normalized location, again, because we want the normalized location as much as we can. And then we're going to trigger at the end, you can see the 4 const guards of these.after guards. So it's going to call every single guard for the after guard. So once the navigation has been completely complete, you call the after guards. This is not the case nowadays in the Vue Router implementation, because we call them a bit too quick. So for example, in your after each, you won't have the actual URL still present on the URL bar, which is it's a pity, because it should be the same one as you have in the router. And this is just the same code, but it doesn't appear, and I already explained it. Now, result location is a bit different, because result location is taking the location, and this location needs to have a specific shape that the matcher can understand. So remember that the matcher doesn't care about the query nor the hash. It only cares about the path. And we have the current location, and then we have a redirected from, because we want to save the information if we went from another location. So the first thing we do is have this match route. So we resolve the route with a matcher. We get a normalized location. And then, because if we have a route that we have a normal navigation, we just set the redirector from in case there was a redirection, and we return that. If not, we have to handle that redirect. Now, in Vue Router, you can handle redirects right into the route records. You can say, if you add a new route or you rename a route, you can still add a new record that points to the old route and redirect to the new one changing the params correctly. So for example, you could change a query param into a normal parameter, whatever you want. So this is, as you can see, there is a recursive call here because we're calling the match location again, which, by the way, that's a typo. It should be result location. So that's the recursive call. And we are normalizing the location to pass an object that is correct for the matcher, etc., etc. Let's go through this. So I hope you're still hanging in there. Then we go back to the navigate on the function, and we're gonna dive into that code. So that code is the one that handles all the guards, and it's not that complicated. If you do it, you can have it simple and still handle complicated stuff. So we're gonna explain why. But first, let's talk about the navigation guards themselves very quickly, just to make sure. So we saw that already, the before each, but there is also the per route guard, which means that the actual logic, the middleware, will be contained in the router.js file and not in the component, because you can also have an in-component guard. And it means that if you want to do lazy loading per page, which you should always do, the logic for the guard will be contained in that file that will be the chunk for your component. So this is very important, later you will see. The way they work is pretty simple, because it's just a series of asynchronous middlewares that can run anywhere. So if you are in post and you want to go to admin, let's say you have a before each. In before each, you call next. So it's going to validate. It's going to go to the before enter of the record, and it's going to say, no, you're not authorized. So we say next false, and we just drop and we stay on post. And the admin.view file will be never fetched. There will be no network request. This is very important, because we don't want to trigger unnecessary requests to fetch information. Now, on the other scenario, if it works, it will be a bit different. But first, just in case, for the people who don't do Vue, in Vue you can transform anything, any component from a static import to a lazy import by just wrapping a dynamic import into a function. So you can do this at any level. It doesn't matter if it's a router or if it's a component, and it works. So if you do this, and what is going to happen is that when you trigger the before enter, you're going to await that chunk, that file, and once you have the component, then we can read the code before route enter, and we can execute them. We cannot execute the code before having the chunk. And because they are executed in series, you have to wait every single time for every component. But this is important because you don't want to trigger an unnecessary network request for a file that you may not need, because the navigation may be canceled before you get to that nested route. So navigate looks a bit like that. Now the code is a bit long, but you will see there is a lot of repetition. So at the beginning, you can notice that we're returning a promise that with nothing. And the arguments that we have is route location normalized and route location normalized. So we have two router locations that are normalized, the same shape. So the other important part is this array. The guards is going to be an array of functions that return promises that we're going to use all over the code. And we're going to see a lot of these extract, not a lot, 2 times, extract component guards. Because we're going to extract the guards from the actual files. But we have to extract them in a way that we trigger the network request only if we know that we're going to execute that guard. So that function is going to handle that. Now, this is the before route leave. So we have 3 types of guards in components. We have before route enter, before route update, before leave. The before leave is the first that need to get executed. So we're going to filter in the match array of the location we are coming from, which is going to be an array of the records of the routes. So why an array? Because you have nested views that will be the parent, the child, the nested child, etc. And because we want to trigger first the nested child before route leave, we're going to reverse the array. So that's why we have a reverse at the end. And then we're just checking, we're comparing the match from with the one from to. So we just want them, the one that were in from, but that are not in to. So it means that we left that page. And then we're passing the to and the from, and we're passing the string before route leave. But we're going to talk about extra components just after that. Then what we do is this very simple code, which is a for loop with an await. So we're just Because we shaped those guards in a way that we can call them as function and await them, we can just write this for loop, and that will be running our queue of guards. That will be it. And will it work? No. So let me go a bit like that. So, are you working? Yep. We have the same code for all the guards. I say same, but it's not exactly the same. We have this function guard to promise fn that transforms the guard into a function that returns a promise that will pass the next function to the guard, so that if you call it with false, it will reject the promise. If you call it with nothing, it will validate the promise. And then we have, again, the for loop with await. And then we have these extra component guards, which is for the before route update. So that's why the filter is a bit different, but pretty much the same idea. It doesn't scroll. And then it goes. I'm just going to scroll like this. Then we have the await again with the for loop, because there is just the same thing, and every time we are emptying at the beginning. And this is the before enter, so those are the ones that we have in the record, and you can see that the logic is pretty much the same. We verify that there is a before enter if there is one, and we were not on that component before, so it's not on the from, the location we were at. We push that to the guards, and then we execute them the same. And then we have the same for the before route enter, so the filter is going to be different. It's going to be the ones that were on to, but were not on from, so the new ones. And at the end we have, I'm pretty sure I replaced this code, but whatever. This is pretty much the same. It should be a for loop. It's just that I refactored on the real code and I copy-pasted and I probably forgot to change that. So this is a lot. I'm going to skip all the steps because it's crawling up all the time. And now let's talk about extract components guard, which is the last one I'm going to show you. So you have at the beginning these type guard type, which are three strings: before route enter, before route update, and before leave. And you can, so we're returning the array of function that return promises, which is the type that matches the other way. And then we have this transformation. We transform the match array into an array of function that return the promises. And this is a simplified version that doesn't handle the named views on Vue Router, but it shows the intent very well. So we are extracting the component from the record, and we are making sure that we are resolving it if it's a promise, and if it's not, we're just gonna get the value right away. And then if there is a guard, we're gonna call again the guard promise fn, and we're gonna await them. So this way, because we are awaiting the result component, we are solving two problems. We are solving first the lazy loading, which means that if we are doing the lazy loading of the page, we'll wait for the page before it's loaded. So it means that we will still enter the page once we have the component. The URL will not change before. And if there is a guard, we will wait for it as well. So we have all the things. And I want to just summarize a bit, because I know that the code is not always that easy to understand, especially on the screen. But we have this router that is on top of the history and the matcher, and the history and the matcher never communicate between them. There is always the router communicating with the history and the matcher, and it will be always the router exposing the public API. What I'm trying to do with the new write is to equally distribute the complexity of the code and the size among these entities to use a better typing system, because I reckon that the typing that we have with Flow is pretty bad. We don't use it well, and because we have been finding problems upgrading, we have pretty much given up. And because we're rewriting the whole thing in TypeScript, it makes much more sense to use TypeScript as well for the router. And that will allows us to refactor also more often to make sure that we keep the first rule true, and to have more tests in the browsers, because nowadays the tests we have are not super complete, so we can break things between releases in different browsers, notably older browsers, to be honest. But it would be nice if we have these automated browsers test running with browser stack or something similar. And we want to make it easier to contribute as well. So for example, I'm talking with a friend to organize a day, in a Sunday, a contribution day, so I will be able to mentor people in Paris in person, so they can contribute to Vue Router. So I will make sure to have some tickets ready that they can be used, and with a very wide range of complexity, from documentation for people who just want to write or because they are good at writing documentation, for bugs that can be very browser specific. And before finishing the talk, I just want to thank you, my sponsors on Patreon. I have a Patreon. I try to use it to sponsor the work I do on open source. I wanted to include the one from GitHub, but I don't have the page yet on sponsor at GitHub, so I couldn't. But if you want to support me, you want to allow me to do more work on the router, this is one other way to make it happen. I hope you learned something about routing today with Vue Router, that it motivates you more and it helps you to shape the routing in your applications. And thank you for your attention.
All right, so thank you. Thank you for the presentation. Would you like to join me for the conversation as well? So your Russian is getting better, as I can see.
I don't remember the pronunciation. It was spasibo? No.
Spasibo is...
Spasibo.
That's good enough. That works for me. Pavel is wondering, why does every framework developer have to write their own implementation of history and router? Why not come up with a single unified API around existing history and things like matchers, since almost all solid frameworks mostly do the same things and use the same patterns?
So it's true. I also asked myself the same question. And when I was looking at the different implementations, for example, the one that React Router uses, I wasn't happy with the implementation they have. I found it too heavy, and I found it to go too far in the boundaries and the things they do. So I just think that people like to work things differently, and they will divide responsibilities differently. And I never talked with Ryan Florence or Michael Jackson about routing, but I would totally love to. And I've seen other agnostic implementations of histories and router, and I think that it's because people want to put different responsibilities into them. So that's why you find different implementations. It's hard when you're doing it's the same problem as open source. When you're doing the things on your free time, communicating with people to move things forward can feel very slow and very frustrating. So that's why I think people do not communicate enough to build this kind of stuff together.
Well, just once you bring up one question, more things pop up. What about altering router configuration on the fly?
Well, that's the dynamic routing part. So having dynamic routing will allow having declarative routing on Vue Router, for example. And it's pretty much what I explained. What the problem is, it needs a ranking system that automatically ranks routes. And once you have that and you prove that it's correct, it's good.
Yeah. And Eugene is actually asking a similar question. So you use your own realization implementation of the history. Why not another one like, let's say, a React router?
It wasn't good. It wasn't what I wanted. It wasn't having the API I wanted, or it was doing too much.
Yeah, so you being the member of the Vue.js core team, is this something that we should be looking out for, like in general? So it seems like Vue, especially over the last year, has been growing and evolving so fundamentally in a way, like really... I have to see something here. So what do you... Yeah, maybe just me. Where is it heading? Is it like it's a fancy new thing, a fancy new feature coming out that everybody should be awaiting? That you're not allowed to speak about, but we'll share here because everybody is friends around here?
No, there are no new things I'm not allowed to speak about. The new thing coming is Vue 3 with very different things, some performance improvement, but there is still a long way to go because it's being rewritten, and many things are changing. And we're trying to collaborate a bit more with the people so that there isn't only one person writing the whole thing. I mean, Evan doesn't write the whole thing either, but he does write the major part, and we want to change that a bit as well in the future. About features, the biggest one is pretty much better TypeScript support. There is performance as well, and tree shaking, like smaller bundle size and a lot of performance improvements. Okay.
Well, that's something to look forward to. I think we have more questions, but we're also running a bit behind schedule. So you'll be available in the discussion zone. We'll bring you there. So if you have any questions, you can also raise them right there. All right, with this in mind, please thank you so much for being with us today.
Thank
It's
you.
wonderful. Well done.
Thank you.